Okay, please start.
Sorry for Japanese. So I will explain my research work very briefly. So because I am very poor person to explain them in English. So the title is regarding the working like mechanism analysis for understanding a mechanism of structure by using the multi-body dynamics. So actually, recently, the multi-body systems, like this kind of which struck by the many component, is the very in this case the multi-body dynamics is the very good way to describe this kind of complex system. So the German group focus on the neuron wave equation, and also they extend this theory, and finally they made the method as a multi-body dynamics, and also the other professors group from America. So in this case, in fact multi-body dynamics required from the industrial area. So in this part, this group professor developed the other way, and also they make some mathematical model regarding the multi-body dynamics. And also recently, the multi-body dynamics is very useful for describing this kind of the human body structure. The one group focus on this the solid linkage by using the multi-body dynamics. Also, the other group focused on the other approach. The multi-body dynamics has the two approach. The other professor focused on the other multi-body dynamics for describing this kind of the behavior. So in fact, when someone focuses on this kind of the model, this model will show the very specific dynamics regarding the passive walking. In this case, it is possible to describe by using the energy
Consumption.
Yes. And in this case, so the other professor focus on this kind of the musculoskeletal structure case. In this case, so the system is very complex, and also that's why they focus on the coordination between the body, bone, and the muscle. So in this case, so it is they can do that. However, so in this case, so this model can describe the one gait, for example, the walking or running or something. However, it is tough to explain the another gait. Why another gait will be occur? So it's tough to explain that. In this case, so of course we need the muscle. However, so why we need the muscle? So that's why if we focus, so there are many gaps between this simple model and this complex model. So that's why I add the middle part. So if we focus on the structure and dynamics, so we can describe another way. It means, so if for example, we can evaluate structure point of the structure, and also we can think about the continuously of the changing gait or something. So that's why this part is very useful for understanding the two parts. So that's why I focus on the closed mechanical linkage. So this is the Tail-Janssen mechanism. This closed link mechanism will obtain the smooth walking pattern. So the one group focus on that mechanism, and also they optimized its orbit. and the other group focus on more engineering side. However, no one focus on the function of the structure structure of the mechanism. So that's why this is my hypothesis part. So that's why we need more seriously investigate the structure of the mechanism. So that's why multiple dynamics is very useful for analysis that this is the mathematical way. This is my purpose of PhD's course. So I focus on the closed linkage and also a working mechanism. And so first is I will develop the mathematical model of that working mechanism. And also we will check and also evaluate a basic property of that mechanism. Also, I add something real freedom to the multiple linkage, and also I expect to get another motion from that. And also, basically this working mechanism, this linkage can work. So that's why the main part is to analysis the working mechanism of this. So this is a flow chart of the dynamics model in multi-body dynamics. From the Newton and Euler equation is the start point, and also someone at the virtual work principle to that, and also at the Lagrange multiple method. And also they consider regarding the kinematic constraint between one links and another links. After that, this is also the motion equations. And finally, they mixed as one differential algebraic equations. This is the for example, this is the Taylor series mechanism. So I set it coordinate one by one. In this case, the Taylor series has the 12 linkage. So firstly I set the coordinate, and also I described the kinematical constraint like this. So this part mentioned between the one links and another links, the fixed point. So after that, I calculate the mechanism, because before we try to focus on the working mechanical system, so we will check this mathematical ways. I mean, so basically, this multi-body dynamics is depend on the numerical analysis. So that's why in this case, I chose the four order liquid method, and this is the result of that. And also, this is velocity and acceleration analysis result. In the Taylor-Sense system case, so this point is the changing point from the supported phase to the何フェーズでしたっけ? U 弱って何でしたっけ? Swing phase. This point is the changing point. So in this case, the velocity.
So accumulation up to
yeah.
Using.
Right, like that.
Because during swinging you are using this energy, right?
Sorry, I could say.
During swing, you're using the energy, or you are collecting the energy?
So in this case, so I couldn't check the energy of that. I just checked the velocity and acceleration. However, so if we focus on the energy part, so this kind of the basic property need required.
Yes.
Well,
It's clear.
So okay, I will skip the some part. So I will focus on the working part only. So for example, Taoyuan mechanism and Cran linkage and Chebyshev working linkage is the one of very famous the linkage, working linkage. So I compared among the three mechanisms by using the velocity and the 仕事率仕事率って何でしょう
Hour efficiency.
Effectivity of the energy. Or?
Yeah, and the kind of energies. So in this case, the Shiharen, he is the one of the great professor regarding the multiple dynamics. So he already described this kind of map. So, for example, in this map, it's very useful for evaluate the working cost. For example, in human working case, this is here like this, and after that, there are no mention. If we run, there are another line like here. The one way is the speed is the one of good key to transit from the one gate to the another gate. So this evaluate map is very useful for comparing that. That's why I selected this. This is the result of the mechanisms. So in Taoyuan mechanism case, so this mechanism has got a very high torque when this mechanism move on from the ground to the swing planes. This part, from this part to this part. So in this case, this mechanism requires the high torque when this mechanism move from the ground. In the current linkage case, so this will move like this, like a spider. In this case, so this part is very, how to say, strongly changed. In this case, so this mechanism, the mechanism case, if mechanism touch the ground, the high torque required. And also, this is a Chebyshev linkage. So this is a very classic one. So in this case, this part will show the one orbit here and also copy from this part to here. And in this case, the torque has the some, how to say, the positive part and negative part is, the, how to say, the amount of this is quite different. I mean, the previous one case, so there are really the similar. However, in this case, there are the 2 or 3 times gaps here. So this is the very interesting point. And also, finally, I add the 3 torque on the one graph. In this case, the Chebyshev linkage is the best linkage for working in this case. why chip-chip linkage is very useful for working. So in this time, so I just confirm that talk, and also we will consider regarding the structure of the linkage. So now I focus on that part too. Then after that, I will submit as a journal paper, including that previous dynamic model too. Thank you very much. This is my.
Okay, question and discussion, please.
Well, frankly speaking, I thought that I will not be able to generate questions, but I am. The question is, do you think that in your work could have any sense to apply evolutionary algorithms?
Sorry, I don't know what that algorithm is.
Very good question.
Evolutionary algorithms.
Evolution.
Evolutionary algorithms. These are natural searching. You know, because in fact you are looking for some optimal parameters of the system with minimum energy and maximum performance.
Yes.
And in fact, there's lots of. I'm sure there are lots of people who are working on pace optimization and how to, you know, there are many videos of how they have the skeleton, and then after many NEAT, for example, NEAT is one of our algorithm which was tested in our laboratory. But I mean, I'm not sure if you are familiar with evolutionary computing, but I really suggest to maybe think about only about, you know, this in theory when you will work on PhD final, at least mention what is better, this kind of analysis or other kind of analysis. Okay, and I have one thing very interesting and very exciting. Pitoyo is Professor Hartono is from Chukyu University, and I spent with him about 3-4 days last in July this year. I was here.
Okay.
I'm more Japanese than and this university is a university of sport people. So there are many. There's a person who was an Olympiad. So they are drinking together in the bar, and also there are doctors who are advising the sport people about how to, you know, move and something, you know. And the question is that if you would make a video of the person, and based on analysis of his movement, could you advise him how to be more efficient? Is that make sense regarding to your research? Because one thing is create something which will need less energy.
Yes.
As far as I understood. But second is to observe the human and say him, you know, not take head this but this, and you will save energy.
Yes.
Because the same is the huge business is in fitness.
Yes.
Huge business. You would become millionaire if you would create a system which would, you know, put on the Xbox, or there is a dance central and fitness central and this thing advising that please don't use your leg or hand here but here. But it's, you know, but based on this computation. So I just want to ask if there is potential for it.
Yes, basically, so if someone just focus on the energy cost, so it mentioned the maximum cost or minimum cost. However, why that decided? What kind of what is the mechanism behind of that? If we focus on the structural way, so in this case, so I can describe like this. So this is the the most how to say most
Complex.
yeah, and also that this is the very important part of the multi-body dynamics.
Yes.
So because this part mentions the connection between the one linkage to another linkage. So in this case, I described the x and y and theta values. However, so we can pick it up from this one. I mean, so, just pick theta or the other x coordinate or something. So and also this. If we evaluate that part, we can suggest which part is the more useful or more.
For that movement.
Yes, yes, yes.
So you can advise, but frankly, you can advise the person to use more your leg or use more something and to be more efficient. So like a marathon runner is running, and if you are making him a video, you can advise him that I don't know what to save energy, and that's very important. It's very important.
Yes, 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 yes.
So I think it's very very interesting.
So the behind of this concept is to understanding the internal dynamics of the structure. So for example, this is the one way for describing that. So yeah, that's why. So.
But there are two ways how to use it: either creating a system, either advising the human to be more efficient, as far as I understand.
Yes.
If I'm not sure if I'm correct, but it's very.
Yeah. So basically, in the method case, one goal is how to say that someone already developed the software for calculating the system of car or airplane or the very, very complex system. So for example, the Adams or other very famous mechanical analysis software is based on these theories. So this is the one, how to say, the main topics. However, so recently Professor mentioned that so other ways exist regarding the more human behavior or human motion, something like that. So this is also the recently hot topic too.
Okay. Sorry, Maria wanted to ask something.
Mari. Yeah. Can I have some comment? Yeah, the genetic algorithm, right? The evolution algorithm. We are standing on the opposite side. Okay, clearly, because the genetic, I believe, true evolutionary process is not just a random process, right? Basically, the genetic algorithm uses the randomness by selecting the global evolution factor. Okay, selecting this, but I believe internal factor, internal mechanism, dynamics. Okay, he have his own preferences. His have the advantage, disadvantage. So then he got some root. He has different preferences. Then he got their own root. I believe the individual, the living things or the things that have some own preferences, direction. So then, I believe that the power. So then, finally, even if we can observe as a random process, but it's not, I believe. So then, individual process is getting growth in their own direction.
Yeah, but I think that the randomness can be a little bit limited by selection pressure and by the criteria function. So in fact, you are not totally random. You are only partially random. So you are random in the area where you can say that why you are here.
There are two parts. One is such as the wandering process, but some are the bias power. But I believe in the individual preference, and then some of the this the guy want to go this direction and finally reach this in a different way. And then we are there are many people treating that this is a black box put together and parameter fitting, that's all. But in the viewpoint rehabilitation that he's working, I want to coach him. Okay, you have to change this motion for you. But that's a different the coaching. I have to say some different person. because this we know the mechanism. Okay, because his muscle is doesn't work this side, so then he have to do that, not just randomly, right? So then that is the really point. So then I have to think about the mechanism, not just black box, parameter fitting, and reinforcement learning, reversing. And then instead of that, I want to know what exactly works, why. Then if once we know the mechanism, okay, I can put some other solution. That is my approach. So then, okay, I respect this other approach because it's very general and not depend on the person. Because the reinforcement learning and the just work and
You are
learning,
not interested only on the result, but you're interested on the knowledge which
exactly,
is coming
exactly,
with the
in
result.
the mechanism, what we want to know.
Yeah, I
then
understand
they
that.
can improve
Yeah.
exact point, then teach. That's the point then. Okay, sorry your time, but okay.